Sometimes we could have a class that has mixing static and non-static methods. So for any class, it can have instance variables, and remember, instance variables don't always exist unless you create an object from this class. It can have also static variables, it can have static constants, it can have static methods, and finally it can have non-static methods. Although such combination is possible, but we have to be careful when we have mixing static and non-static methods. The first thing we need to know that since a static method is a method that always exists, regardless if we create an object or not, then make sure that it uses also a static variable or a static method. Because when you call the method without an object, we have to make sure that the variable or the method that this static method is using exists. So this is why a static method can reference a static variable, but not an instance variable. Why not instance variable? Because we cannot guarantee that this instance variable at the moment of calling the static method exists. Also, it cannot call a non-static method because unless it has an object to do so. And this we will see as an example later, that if we want to do that, then you have to pass the static method an object, and inside this object you can call the method because it is already there from the object. Now for non-static method, again, this method exists when an object is created, so it can use static variables and it can use also static methods because the methods and the variables are always there. So a non-static method is guaranteed there because it is created with the object. So it can reference a static variable because a static variable is always there, and it can also reference a non-static method because it is already created with the object. In simple words, if we have a class with a combination of static and non-static members, is that if we have a static method, then it must reference only static variables and static methods. And if we have non-static method, then it can reference any variable and any method, whether it is static or non-static. As an example of a class with a combination of static and non-static methods, we are going to design a saving account class called savings account that maintains the balance of individual saving accounts with all accounts having the same rate of interest. Since we need to maintain a balance for each individual saving account, then we are going to define balance as an instance variable because we need a copy in every object created from this class. However, since we need the same rate of interest for all accounts, for all saving accounts, then we will define the interest rate as a static variable because it's going to be shared by all objects created from this class. The class also needs to count the number of accounts opened by this class. In other words, we need to count how many objects are created from this class. And to do this, we define a static variable called number of accounts, and we increment this variable inside the constructor because every time we create an object, this constructor will be called and this variable will be automatically incremented by 1. In addition to that, we need to define also the following methods. We need to define static set and get methods for the interest rate, and this is an example of a static method that is referencing a static variable. And also we need to define a static get method for the number of accounts, and number of accounts is static, so this is an example of a static method that is referencing a static variable. Also, we are going to define two non-static methods, one for making deposit and the other one for making withdraw. Deposit will affect balance by adding an amount to balance, and withdraw will affect balance by deducting amount from balance. Balance is defined as an instance variable, so it can be accessed only by non-static method. And this is an example of non-static methods accessing a non-static variable. Also, we need to define a method for adding interest to the account balance. And we need to define a get method for the account balance. And we need to define a static method that displays the balance of another account. For adding interest method, it will multiply the interest rate by the balance, and the result will be added to balance. So this method is referencing balance, which is instance variable. It is referencing interest, which is a static variable. And since it accesses instance variables, then it cannot be defined as static. So this is an example of non-static method that is accessing static and non-static variables. For getting the account balance, now account balance is instance variable, it is non-static, so we cannot define this get method as a static because the static methods can reference only static variables. Finally, in the last method, it cannot display the account balance by using get method. Why? Because the get method for the account balance is defined as non-static and this method is static. However, if it is given an object of another account, then it can access get method of that account within the static method. So as we said before, if we have a static method, then it cannot reference any non-static method. But if it is given an object and inside this object it has non-static method, then it can call this method. And we will see this in the next slide for an example. This is the implementation for the savings account class. First, we define the data members. We have three data members. First is balance, which is non-static. It is an instance variable, and the other two are static. If it is an instance variable balance, then it exists within the object. So that means you create an object from the class, then it will exist. But for static variables, they exist in the class. That means you don't need to create an object to access them. You just access them by the name of the class. Notice we have defined them private. That means if we want to set or get any of these values, we need to do that by methods. For balance, we can get the value of balance by using a public method called getBalance. And if I want to get the value of the interest rate, also we have a method that will give me the interest rate. And finally, for the last one, number of accounts, if I want to know the number of accounts, then we use also a method to give me this value. Notice that we don't have a set method for number of accounts because this variable, we want it to be controlled by the class itself. So we don't want the user to change it from outside. Otherwise, we will lose the integrity of its value. It is updated only by the constructor. Notice here, because this variable is used to count how many accounts, and if you want to know how many accounts, you need to know how many objects have been created from this class, and this can be done by the constructor. So notice in the constructor, whenever we create an object, the number of accounts is increased. So we don't have a set value for this variable. However, we have a get value getter for this variable. If we want to know what is the number of accounts, we can simply call this method. In the constructor, as we mentioned, first it initializes balance to 0 and it increments number of accounts by 1. So in other words, every time an object is created from this class, number of accounts will be updated and will be incremented by 1. And each object created from this class will have a separate copy for balance. The set method for the static variable interest rate is defined here, and the get method for the interest rate is also defined here. Both of them are static methods. That means we can change the interest rate directly by using the class name. The other static method is for getting number of accounts. If we want to know how many accounts were opened from this class, we can simply call this method by using the name of the class rather than creating an object and calling the method from this object. For depositing an amount of money to balance, we use non-static method deposit, and for withdrawing money, we use withdraw method for deducting an amount from balance. Now for deducting or for withdrawing, notice that it retains a value. This value is the amount deducted from balance. If there is enough or if there is sufficient balance, then this amount supplied as an input parameter will be deducted from balance and will be retained as a retained value. However, if there is no enough balance, so if the amount of money we want to withdraw is larger than balance, then simply we will retain 0 as an indication that no money has been withdrawn or deducted from balance. Now for adding an interest, as we mentioned, that we multiply balance by the interest rate. Balance is non-static, interest rate is static, and the result, which is interest, is added to balance. And since we are referencing non-static variable, then we cannot define this method as static. It should be defined as non-static. To get the balance of the account, balance is non-static, so we need to define this method as non-static as well. In the last static method, show balance, it cannot use get balance to display balance of the current object. Why? Because get balance is defined as non-static method, and static methods cannot call non-static methods. However, if it is given an object of the saving accounts, then it can access the non-static method of this object. So if account is the object supplied to this method, then it can use get balance of this object to display its balance. So this method, show balance, cannot display the balance of its object. However, it can display the balance of another object if it is given as an input parameter. To demonstrate the use of the savings account class we have just created, we have written a savings account demo class that includes main method, and inside main method we are using the savings account class. Notice that if we have a class that has static variables or static methods, then we can access these static members directly using the class name. So first here, this is the situation we have when we run the program. We are going to have a class. It is called savings account. Initially, it will have interest rate equal to 0 and number of accounts is equal to 0. And why the system initializes these two data members when we run the program? Because they are static inside the class. In the first statement, we are calling a set method for changing the interest rate, and initially the interest rate is 0. And when we execute this set method for changing the interest rate, it will change the interest rate from 0 to 0.01. See that we are not creating any object. Because this method is static, simply we can call this method by using the name of the class. And this is the situation we have when we execute this statement. Then we have created two objects from the savings account. One is called my savings account. The other one is called your savings account. When these two statements are executed, so two objects will be created, and this is the situation that we are going to have. Since savings account has static variables, interest rate and number of accounts, then these two variables will be shared by these two objects. So now we have two objects. One is called my savings, the other one is called your savings. Each of these objects has its own balance value. So this balance is different than this balance in these two objects. And also notice that number of accounts has increased by 2. Why? Because when we created the first object, the constructor for the class incremented number of accounts by 1, which is my savings. And when we created your savings, its constructor incremented also number of accounts by 1. And after creating these two objects, number of accounts will be equal to 2. This is the situation now we have. My savings has balance 0 and your savings has balance 0 as well. Now when we execute this statement, a message will be displayed on the screen. I deposited $10.75, and also in my savings we are going to deposit 10.75. Here when we use the word I, then we are referencing my savings, and when we mention you, then we are referring to your saving. After these two statements are executed, a message "I deposited $10.75" will be displayed on the screen. At the same time, 10.75 will be added to balance, and balance will change into 10.75. For the next two statements, we are printing a message: you deposited $75, but we are depositing into your savings, which is this object. So when we deposit $75 to your saving account, then the balance for your saving accounts will change from 0 into $75. So a message is displayed. At the same time, the balance is updated for your saving. In the next two statements, another message is printed saying you deposited $55, and again we are depositing into your saving account, which is this object. So when you add 55, you deposited 55 and 75, so deposit will update the balance by adding 55 with 75, and the answer will be 130. So after these two statements are executed, a message will be displayed on the screen: you deposited 55, and the balance for your savings will be updated to 130. In the next statements, we are calling withdraw method for your savings. So it will withdraw 15.75 from the current balance, which is 130, and it will update your savings after this deduction. At the same time, the method will retain the amount that has been deducted from the current balance and will be displayed on the screen. And this is what will happen. A message will be displayed: you withdraw 15.75. At the same time, the withdraw method for your savings will update balance by deducting 15.75 from the previous balance. Next, we have an if statement. We are testing for the current balance for your savings, and it is 114.25. Since it is greater than 100, then we will enter the if statement, and two things will happen. A message will be displayed: you received interest. At the same time, the add interest method for your savings will be called, and this method, it will multiply the interest rate 0.01 by the current balance, which is 114.25, and the result will be added to 114.25. And this is what will happen. A message will be displayed: you received interest from this statement, and at the same time balance will be updated because we have added interest to the current balance. In the remaining statements of this program, we would like to show you two ways to get the value of the current balance in any of these two objects. The first method is simply by calling getBalance method, and recall that getBalance is a getter method for the data member balance. The second method is by passing the object as an input parameter to the static method showBalance, and the static method showBalance will call getBalance of the passing parameter object. As an example for the first way, suppose we would like to print the balance for your savings account. Simply we type your savings.getBalance, and getBalance method will give us the balance, and println will print it on the screen. And as an example for the second way, if I want to print the balance for my savings account, then we pass my savings account as an object parameter to the static method showBalance, and showBalance inside will call the object's method getBalance and will print it on the screen. Finally, if we want to know how many saving accounts did we open today, we call the static method getNumber of accounts, and this static method will retain the value of the static variable number of accounts. Since we have created two objects from the class savings account, then the value for the static variable number of accounts is equal to 2. So this is why when we call the method getNumber of accounts, the retained value will be equal to, since we have created two objects from the class savings account. By this example, we have completed the discussion of static and non-static members when we define them inside a class.